Salam, peace be upon you. My name is Mohammed Layiq Sediqi, the father of Holophase. Part 39. Canonical Normal Forms and HLS, the Universal Standard. Remember the language we are learning. There is one field, phi, the holophase, one continuous cyclic movement from which all of reality unfolds. When phi begins to change, its first derivatives appear, and with them, the three dimensions show themselves at once. Time as omega, space as k, and motion as v, built from both. Every higher derivative is a finer question about how phi changes, and each one casts three shadows together: a time shadow, a space shadow, and a motion shadow. These echoes mix and weave into one another, forming the patterns we call fields, particles, bodies, thoughts, and worlds. In this picture, everything that exists is a living tapestry of phi, endlessly echoing through its derivatives and their dimensional shadows. Today, we listen to just one of those echoes. We now continue our profound journey through Episode 8, the pure abstract language of the Holophase audio series, moving to Part 39, Canonical Normal Forms and HLS, Book 8.12, the Holophase Language Standard. We have reached the final summit of the abstract mountain. For 39 parts, we have climbed from a single seed, the field phi, to a complete living language that can describe an entire universe. We have discovered representation freedom. The same story can be written in endlessly many coordinate systems. We have discovered the symmetry group, the perfect rephrasings that change the symbols while preserving all the meaning and all the grammar. But now a very practical problem appears. If there are infinitely many ways to correctly tell the same phi story, how do we know when two different expressions are actually the same? How do we avoid confusion? How do we compare, communicate, and build physics in a clear, unambiguous way? Today, we solve that problem. Today, we introduce the Holophase Language Standard, HLS. It is the universal rulebook that tells us how to write phi in a single, shared, canonical way. It is the dictionary, the grammar book, and the style guide of the language of reality. And at its core is one powerful idea: canonical normal form, the unique, standard way of writing each phi pattern once and for all. 1. The story core. One reality, one standard spelling. To feel what canonical form means, imagine language before spelling was standard. In older English, people spelled words however they liked. The same word might appear as color, 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 or color in the same book. People understood more or less, but reading was slower, and arguments about writing were endless. Then dictionaries and grammar books appeared. They did something very simple but very powerful. For each word, they picked one standard spelling. Color here, center there, one final agreed form. Suddenly, readers across regions and generations could understand each other far more easily. The standard spelling became the canonical form of the word. Now imagine something far more ambitious than English spelling. Imagine trying to standardize the description of reality itself. We have infinitely many coordinate systems, infinitely many ways to write the same equations, infinitely many paraphrases related by symmetry. Without a standard, two scientists could be describing the same phenomenon and not even realize it because their expressions look so different. The Holophase language standard is that standardization. It says, for every equivalence class of expressions that all describe the same phi pattern, there is a single, distinguished way to write it. That distinguished way is its canonical normal form. Two expressions are really the same if and only if they reduce to the same canonical form. So canonical form is like the final, cleaned-up spelling of a sentence in the language of reality. It is the form we agree to use when we want to be perfectly clear. 2. The linguistic role, the universal style guide of reality. In everyday writing, style guides exist to keep things consistent. They tell you whether to use the Oxford comma or not, how to format dates, how to cite sources. These rules are not truths about the world. They are agreements that make reading smoother. HLS plays a similar role, but for the language of phi. It does not change reality. It simply chooses a clear and consistent way to write what reality is doing. HLS fixes things like which order we write derivatives in. For example, we might agree always to write time derivatives first, then spatial derivatives in a fixed order. That means we write d cubed phi over dt, dx, dy, and never dy, dt, dx phi. Different orders may be mathematically equivalent, but HLS chooses one. Which sign conventions we use? We pick once and for all what we call positive orientation. We decide that positive phase wins counterclockwise, that positive charge corresponds to positive winding, that direction plus x points this way and not that way. How we normalize. We might insist that, whenever possible, patterns are scaled so that their largest derivative takes the value 1, or that certain reference values are fixed. This is like choosing a standard volume on a measuring cup. How we compress. HLS tells us how to introduce abbreviations for repeated structures. Instead of writing out an infinite series, we write sine omega t. Instead of expanding everything into tiny pieces, we allow certain standard building blocks as primitives. Together, these conventions form a universal style guide. Given any phi expression, if you obediently apply all of the HLS rules, you eventually arrive at its canonical normal form. That normal form is what we treat as the official way to write that particular phi pattern. 3. Scientific essence, from many expressions to one identity. The scientific heart of canonical form can be stated in one question. Given that many different expressions can describe the same phenomenon, can we find a rule that selects a single, unique representative from each family of equivalent expressions? You already know one simple example: fractions. The fractions 1/2, 2/4, 3/6, and 50/100 all represent the same number. We decide that the canonical form is 1/2 in lowest terms with a positive denominator. We have an algorithm using the greatest common divisor to reduce any fraction to this form. If two fractions reduce to the same lowest terms, they are the same number. HLS generalizes this idea to phi. Instead of just multiplying numerator and denominator, we now have a whole arsenal of transformations: shifting by a constant, rephasing, changing coordinates, using symmetry, and algebraic rearrangements. The equivalence class is the set of all expressions you can reach from a given one by such allowed transformations. The canonical form is the single expression in that class that obeys all of the HLS rules. You can think of it as the fingerprint of the pattern. Different messy expressions may belong to the same equivalence class. If so, they share the same canonical fingerprint. Different physical situations have different canonical fingerprints. In this way, canonical form turns the vague notion of these two are really the same into a precise, checkable statement. Reduce both to canonical form. If the results match, they are identical at the level of the language. 4. Dimensional expression. Standardizing time, space, and motion together. Because phi always expresses itself in 3 echoes at once, HLS must standardize all 3 dimensions in a coordinated way. For the temporal dimension, we choose a standard time coordinate. In a laboratory, we might pick t equals 0 as the moment we start the experiment. In cosmology, we might choose the Big Bang as time 0. Canonical form always expresses events using this agreed time coordinate. If you use a different clock, you must convert to the standard one before you claim to have the canonical form. For the spatial dimension, we choose standard axes. In a lab, x can point east, y north, z up. On Earth, we might align coordinates with latitude, longitude, and height. Canonical form always uses these reference directions. If you use a tilted coordinate system or a curved grid, you must straighten and transform your description to the standard axis before claiming it is canonical. For the kinematic dimension, motion, we choose standard frames. In simple situations, we may choose the frame in which the laboratory is at rest. In relativity, we may choose freely falling frames or an agreed inertial frame. Canonical form uses these standard frames to express velocities and accelerations. If you observe from a moving rocket, you must translate your data back into the agreed frame. The important point is that HLS does this in a tri-unified way. Because time, space, and motion are deeply entangled, you cannot standardize one without affecting the others. Choosing a different rest frame changes both time readings and space coordinates. HLS provides the full recipe, how to transform any consistent description into the shared tridimensional standard. When two observers using different clocks and different coordinates both reduce their data to canonical form, they get exactly the same answer. That is how they know they have observed the same phi pattern. Phi, position in the master tree, pruning the wild growth. In our master tree metaphor, phi and its derivatives generate an immense wild growth of possible descriptions. Branches twist, split, and recombine in countless ways. Any given pattern can be written with enormous redundancy. HLS acts like a careful gardener. It does not change which branches are alive, but it prunes away unnecessary twigs, straightens certain branches into standard shapes, and labels them consistently. Think of a vine allowed to grow freely. It wraps around posts and trees, looping back on itself. If you want to study the structure of the vine, you might cut away extra loops, guide the main branch along a trellis, and label each junction. You have not changed what the plant is. You have simply placed it into a clear, visible form. Canonical form is that trellis representation for a phi pattern. The underlying pattern, as a piece of the living tree of phi, is the same. But when written in canonical form, its structure becomes easy to see, compare, and study. This is why canonical form belongs high in the master tree. It is not about new content. It is about clarifying, standardizing, and making the existing content transparent. 6. Relations to neighbors. How canonical form ties the whole language together. Canonical form touches every other concept we have developed. For derivatives, HLS chooses the unique way to order and normalize them. All mixed partial derivatives are written in a standard sequence. All units are converted to agreed standards. This makes expressions directly comparable across problems and domains. For symmetry groups, canonical form is the test. If a transformation is truly a symmetry, applying it and then restandardizing must bring you back to the same canonical expression. If canonical form changes, then the transformation is not a true automorphism of the language. For topology, canonical form lifts out the invariants, the winding numbers, linking numbers, and other discrete features that do not change under smooth deformation. These invariants are naturally written in canonical form because they are already stable under many changes. For information, canonical form is the most compressed, lossless representation allowed by the HLS rules. It is close to the idea of minimal description length. No shorter description in the standard language can capture the same pattern without losing information. For epistemic access, canonical form is what we aim at when we analyze data. Our instruments see phi through noise, distortion, and local coordinates. Data analysis is the art of cleaning, transforming, and re-expressing those raw readings until they match a canonical pattern. Only then can we meaningfully compare different experiments or build universal laws. For falsifiability, canonical form is the comparison point. If two experiments, both claiming to study the same phenomenon, lead to different canonical forms, then either they study different phenomena, or the HLS rules or symmetry assumptions are wrong. Either way, something real has been revealed. 7. Semantic meaning. Unambiguous communication inside reality. What is the semantic work of canonical forms? In simple words, they make communication inside reality unambiguous. Imagine the different communities on Earth used completely different calendars, units, and naming systems, with no standard conversion. It would be almost impossible to coordinate science, trade, or even conversation. Canonical forms, in all their everyday disguises like SI units and UTC time, are what make modern civilization possible. At the level of phi, canonical form does the same for the universe itself. Different parts of the universe, different observers, different instruments, all see phi from their own perspective. But if the underlying language is phi, and if there is a well-defined canonical form for its patterns, then all of those perspectives are, in principle, convertible into the same standard description. In this sense, canonical form is not just a human convenience. It is how a single reality can express itself consistently through many possible viewpoints. It is what allows one story told many ways to still be one story. Stability and falsifiability, when standardization itself breaks. Of course, we must test even this idea. It is possible in principle that canonical forms cannot be defined consistently for all phi patterns. If so, that would be a profound limitation of the holophase vision. Problems can arise in several ways. First, non-uniqueness. If our canonicalization algorithm sometimes gives two different final answers for the same initial expression, depending on the order of steps, then the definition is not well posed. We would need to refine or restrict our rules until the outcome is truly unique. Second, over-identification. If clearly different physical situations collapse to the same canonical form, then our equivalence classes are too large. We have thrown away information that actually matters. In that case, we must either shrink the symmetry group or enrich the canonical description. Third, non-existence. There may be strange patterns of phi for which no configuration satisfies all our chosen standardization rules. In such a case, we must decide whether these patterns are truly allowed in the language or whether our rules are incomplete. If, after deep work, we found that no consistent system of canonical forms could exist that matches physical equivalences, this would be a serious blow to the Holophase program. It would mean that reality, at its deepest mathematical level, resists being written in a single unambiguous standard. But if canonical forms can be consistently defined and aligned with experiment, then HLS becomes one of the strongest pillars of the entire framework. 9. Examples across scales. Recognizing canonical form in daily life. Canonical forms are not exotic. They are everywhere around you. When you follow a recipe that tells you 1 cup of flour, 1 teaspoon of salt, you are using standard measures. A cup is not any random container, it is a standardized volume. The canonical form of the ingredient is that standard amount. When you use GPS, the messy description next to the old tree by the river is replaced by clean latitude and longitude in a standard geodetic system. No matter who reads those numbers, they point to the same spot. The canonical form of the location is that pair of coordinates. When doctors record your temperature in degrees Celsius or Fahrenheit, they are mapping your body's thermal state into standardized units. The actual energy in your atoms is complex, but the canonical representation is one simple number on an agreed scale. When scientists share results, they almost always convert to standard units: meters, kilograms, seconds, Kelvin. That act of conversion is itself a canonicalization step. These examples are shadows of what HLS does at a deeper level for phi. They show that canonical form is not just a theoretical luxury, it is the everyday backbone of clear understanding. X. Human and abstract analogies. Passports of reality. One final analogy, the modern passport. Billions of human lives are wildly different. Cultures, languages, stories, and beliefs vary enormously. Yet, when you travel, all of this individuality must be compressed into a small booklet that border systems can read. So the world agreed on standards: dimensions of the booklet, machine-readable lines, biometric photo rules. Your unique human life is mapped into a canonical form that any airport can process. Phi is like the deep living person. The canonical form is like that standardized passport. It does not capture every detail, but it captures, in a precise and unambiguous way, the essential identity needed for certain kinds of interaction and recognition. In the Holophase vision, HLS plays this role across all of physics. It is the standard that lets different laboratories, different observers, and even different theoretical descriptions agree on what they are talking about. 11. Return to phi, one field in its clearest expression. As always, we return to our root. There is one field, phi. It moves, differentiates, and echoes into time, space, and motion. From that movement, all the rich hierarchy of patterns we have discussed arises. Derivatives, topology, holonomy, information, dimensions, representation, symmetry. Canonical normal forms and the Holophase language standard are not additional decorations on top of phi. They are the way phi's own structure becomes readable, comparable, and communicable. They are the clear glass that lets us see the field without distortion from our arbitrary choices. With this part, we have finished the abstract construction of Episode 8. We now have the alphabet of phi, the grammar of derivatives, the higher-order structures of topology and holonomy, the semantic layer of meaning and information, the triune-dimensional expression in time, space, and motion, the bridge to physics through mapping, filtering, and epistemic access, the freedom of representation, the organizing power of symmetry groups, and finally, the unifying clarity of canonical forms and the Holophase language standard. This truly concludes Episode 8, the pure abstract language. You are now fully literate in the Holophase language at the abstract level. You know not only that there is one field phi, but also how its story can be written, rewritten, standardized, and shared without ambiguity. From here, we cross into Episode 9. There, we will watch this pure language take on the garments of a particular universe. We will see phi become mass, become light, become fields and particles, become stars and atoms and living beings. We will see that physics, in all its forms, is just phi speaking in canonical, structured ways within a specific reality filter. For now, pause at this summit. Look back at the path we have walked. From one simple idea, a cyclic field taking values on a circle, we have built a whole abstract organism of language. And with canonical normal forms and HLS, we have given that organism a clear, universal standard by which it can recognize itself across all perspectives. Gentle recap of the whole abstract journey. Before we leave this abstract mountain, let us walk once more, slowly and calmly, through the path we have taken, so that the Holophase language standard sits in its true home inside the full story. We began with a single, humble idea, that all of existence can be described as one cyclic field, phi, taking values on a circle. At first, this might have sounded almost too simple, like saying everything is just a vibration. But we did not leave it as a slogan. We unfolded it step by step into a full language. First came the alphabet, the values of phi themselves, and the fact that phi lives on a circle, not on a line. This circular nature is what makes phase special. After you go all the way around, you return to the same point. This gave us the possibility of winding, loops, and memory. Then came the basic grammar, derivatives. We asked how phi changes, and each time we asked that question more finely, we created a higher derivative. At every level, each derivative produced three shadows at once, one in time, one in space, and one in motion. This threefold echo is what we called the triunity of dimensions. As we climbed, we discovered topological structures, knots, loops, and winding numbers that do not disappear when you stretch or bend the field. We saw how holonomy, the memory that phi carries when you go around the loop and come back, gives us a natural way to encode history and context in the field. We layered meaning on top of these structures. Patterns of phi became carriers of information, not just raw values, but messages, codes, and signals that can be read and interpreted. Information became, in this vision, not something separate from physics, but simply structured organization in the phi field. We then recognized that every pattern appears simultaneously in three dimensions: time, space, and motion. We did not treat these as separate worlds, but as three different readings of the same underlying movement. Phi does one thing. We read it as duration, as extension, and as change. From there, we built a bridge to physics. We spoke of mapping, how to link abstract phi patterns to concrete physical quantities like mass, charge, and field strength. We spoke of filtering, how different universes might correspond to different ways of reading the same language. We spoke of epistemic access, how limited observers within the universe can measure, infer, and test the underlying field. We then step back and notice representation freedom. There are many ways to write the same story, many coordinate systems, many mathematical dialects. We insisted that the true content lies in what survives these changes. Next, we studied the symmetry group, the deeper rephrasings that change phi itself while preserving all grammar and all rules. These symmetries gave us the power to understand conservation laws and deep regularities. Now, finally, we have arrived at canonical normal forms and HLS. This last move does not add new content. It organizes what we already have. It says, given all this richness, here is how we can write it in one clear, universal way, so that confusion does not drown understanding. So when you think of HLS, do not think of a cold, bureaucratic rulebook alone. Think of it as the final act of care in a long process of listening to reality. We listened to phi, discovered its behavior, its echoes, its loops, its symmetries. At the end, we chose a way to write its story so that any mind, anywhere, at any time, could in principle read it and know exactly what is being said. One last time, remember the big picture of the holophase language. There is one field, phi. From its motion arise first derivatives, and with them, time, space, and motion together. From repeated differentiation come an infinite tower of finer and finer echoes. At each level, patterns of phi can be noted, can remember, can carry information, can form harmonies and structures. Through mapping and filtering, these patterns become, for a given universe, what we call matter, energy, forces, and laws. Through symmetry and canonical form, we understand not only what the patterns are, but also which parts of our description are essential and which are just different ways of saying the same thing. In this sense, HLS and canonical forms are the final tools that make the language of phi truly shareable. They are what allow this theory not just to live in one mind, but to be transmitted, tested, criticized, and refined by many minds. They make the holophase vision not only aesthetically beautiful, but operationally sharp. As you carry this into your own life, you can use the same intuition in smaller ways. Whenever you face confusion, ask yourself, what is the underlying pattern here, beneath all the different stories? What would be its canonical form? What is really being said once I strip away accent, emotion, and noise? That habit of looking for the invariant essence is the same habit that underlies the holophase language standard. And as we step from episode 8 into episode 9, keep this simple sentence close to your heart. Phi is one, its expressions are many, and HLS is the way we recognize the same truth across all its expressions. With that, our abstract journey is complete. The mountain is mapped. The language is standardized. The next step is to watch how this language writes our cosmos. Finally, remember that this entire construction is still only one part of the larger holophase program. Later episodes will return again and again to HLS and canonical forms, using them quietly in the background as we build concrete models of forces, particles, and fields. Whenever you hear a law of physics in this series, you can silently imagine its canonical phi expression standing behind the words, precise, unique, and unambiguous. You are ready for the descent into the concrete world. You are ready to read the universe in its native tongue. Salam and peace be upon you.